Good morning, students. So, today's class we are going to deal with the topic moment of a force. So, moment of a force. It is the turning effect produced by a force on the body on which it acts. Because due to the action of the moment, the body will rotate. Say, for example, consider, say this is fixed end. Say it's a beam. A force is acting here, say force P, and say this distance is say D. A force F acting at this point A, this say point O, this force into this perpendicular distance, or this force, if you keep your thumb in the direction of the arrow, rotate it about this point O, this has a rotating effect. This will rotate this body in a clockwise direction. So the moment of force is the turning effect produced by the force, and it is calculated as the force into arm of force, or we call it as lever arm. In this case, it is P into D. Moment about point O is P into D, and it rotates the beam in the clockwise direction. So, direction is also very much important, clockwise. So, moment is calculated as load into perpendicular distance from the line of action of the force up to the point where the moment is taken. For example, let us consider another one case. Say a force, say F, is say acting at an angle theta at this point A, and if you want to take moment about this point O, if you want to take moment of this force about this point O, this point O about which the moment is taken, this point O is called the moment center. The point O, the point about which the moment is taken is called moment center. How will you find out? Force into, this is the line of action. You extend this line of action of the force. This is the line of action. Drop a perpendicular from O to this line of action. Drop a perpendicular from O to this line of action. Say this point is B and this distance is D. So OB is the perpendicular distance from the point of, from the moment center to the line of action. The line of action of the force, the perpendicular distance from the point about which the moment is taken to the line of action, that is D. So in this case, F into OB. Here the moment about O is given by F into OB or F into D. Perpendicular distance, and this OB distance is also known as lever arm or arm of force. OB is called the arm of force, and this force, this is the direction of the force. You keep your pen in this direction, the tip of the pen, or keep your thumb in the direction of the force. Rotate your finger in the direction of O, at the point about which you are going to take the moment. So the thumb goes clockwise, the direction in which the clock is moving. The needle of a clock is moving is called clockwise direction. So here also the moment is F into D. What is D? OB, this angle is theta, so this is also theta. So OB by OA is equal to sine theta, this is 90 degree. OB by OA, this is hypotenuse, sine theta, or OB is equal to OA sine theta. So moment about O is equal to F into OA sin theta. So the different terms, moment of a force is equal to the magnitude of the force into arm of force. Arm of force is the perpendicular distance from the point about which you are going to take the moment and the line of action of the force, or it is a lever arm of force. O is the moment center. Now, if you have an axis, you consider an axis passing through O perpendicular to the plane of the board or perpendicular to the plane in which the force is acting. This axis is called moment axis. Or axis of the moment. The moment perpendicular to the plane containing the force and passing through the moment center is called the axis of moment or moment axis. So these are the terms when we deal with moment of a force, the turning effect of a force. Let me have some small numerical examples based on this. Okay, we'll see how to find out the moment of a system of forces about a particular point. So refer to this question. Find the moment of the system of forces about B. So asked to find the moment of these forces about B. So moment is, just remember, force into perpendicular distance from the point up to the line of action of the force. So consider point B. I can write moment about B, M suffix B is equal to. So this force 15 Newton is acting at B. So there is no, if the force is acting through that point, the line of action is passing through the point, there will not be any moment. It will not produce any rotating effect because perpendicular distance from the point of application of the force up to this point, that is 0. Consider the second force 10. The moment is force into perpendicular distance between the line of action and this point B. So 10 into 3. So the magnitude is 10 into 3. What about the sign? Keep your thumb in the direction of the load. Rotate it about the point B. When you rotate it, the thumb goes in clockwise direction. So we will take clockwise moments as positive and anti-clockwise moments negative. So 10 into 3 clockwise. Then consider this 20. This 20, this is the line of action. Perpendicular distance up to this point B. This is the perpendicular distance. Force into perpendicular distance. So 20, this is the line of action from here to here. It is 2 meters. So 20 into 2 is the magnitude. What about the direction? Keep the thumb in this direction. 20. Rotate about B. So rotate in this direction. So it will produce anti-clockwise moment. So minus 20 into 2. Now consider this 30. This is the line of action. This is the point. So this is the perpendicular distance. From the line of action to this point, the perpendicular distance is AB or DC. So 30 into 3. This is the direction. Rotate your thumb in this about B. From here, rotate it. So it goes anti-clockwise. So 30 into 3 anti-clockwise. This 30, this direction, moment about B. Rotate it, thumb goes in clockwise direction. 30 into 3, 30 into 2 is clockwise. That plus 30 into 2. So the total moment is 10 into 3, 30, minus 40, minus 90, plus 60. So 90 plus 40, 130, 130, 90. It is minus 40. Unit is also important. Load is kilonewton into distance. So kilonewton meter. The answer is negative. That means the total moment of all these four systems about B is an anti-clockwise moment and the magnitude is 40 kilonewton meter. So just remember the load into distance. To find the direction, keep your thumb in the direction of the arrow of the force. and rotate the finger about the point about which we have to take the moment. The direction of the rotation of the thumb is the direction of the moment. Clockwise moments are taken as positive. Clockwise means for a clock, this is 12, 6, 3, 9. This is the direction in which the needle moves. The direction in which the needle rotates is clockwise direction. Just the reverse is anti-clockwise. This is clockwise direction. Okay. So we'll pass on to the next question. Okay, we are next going to discuss with an important theorem when considering the moment of several forces. When several force system is acting on a body, very useful application of this Variance theorem. That is, the Variance theorem states that the moment of a force about a point or axis is equal to sum of the moments of its components about that point. I will illustrate it. Say for example, there are two forces. Say there is a force P. There is another force, say Q. So the resultant of the two forces is, say, R. There are two forces, P and Q. The resultant forces are. If you want to take moment about any point O in the same plane, all these are coplanar forces, moment of this resultant about O, moment of the resultant about O, or moment of the single force R about O can be written as moment of P about O, moment of this P about O, let me write it as MP, plus moment of this force Q about O, MP plus MQ, that is moment of P and Q about O. This is called the Variance theorem. That is, if there is a single force R, the moment of that single force about any axis passing through O or about any point O is equal to algebraic sum. Algebraic sum means sometimes the moment of P about O, depending upon the location of O, one may be clockwise moment, the moment of the other force may be anti-clockwise moment. So you take the algebraic sum of moments of the components about the moment center. So that is called the Variance theorem. This is a commonly asked question for university exam, and we have to do the proof of this also. So Variance theorem states that moment of a force about any axis or about any point is equal to algebraic sum of moments of its components about the same axis or about the same point. I am going to do the proof of this theorem with reference to this figure. So just looking into this figure, AB is one force F1. F is the force, the single force F, its two components F1 marked by AB, and that F1 is inclined at theta 1 with horizontal. The second component F2, it is inclined at theta 2 with the horizontal. So F is the force which is inclined at theta with horizontal, and its two components are F1 and F2. So F1 and F2, the parallelogram is completed, A, B, C, D, the diagonal F. So it is split into two. Now I am going to take the moment of this force F about a point O. Moment of F about O. I will write it. Moment of F about O is equal to force into the perpendicular distance. This is the force, perpendicular distance from the point O to the line of action of the force. That is this distance. It's marked as D. So that is equal to F into D. Okay. Now, what about the moment of F1, the component? Moment of F1 about O is F1, the force into, I have dropped a perpendicular from O to the line of action. Let it be D1. From O to the line of action of F1, I have dropped a perpendicular and that distance is say D1. So, F into D is equal to F1 D1 plus moment, the second force F2. This is the line of action of F2. I have extended it. From O, I have dropped a perpendicular to the line of action of F2. Let it be D2. So, F2 D2. So, according to Variance Theorem, F into D, the moment of a force F about O is equal to moment of its components about O. So, I have to prove this. So, as a proof, I have made some construction lines here. From D, I have dropped a perpendicular to the horizontal. From B also, I have dropped a perpendicular to the horizontal. So that this total distance AE is AG plus GE. AE is equal to AG plus GE. What is this AG? This force is F1 inclined as theta 1. So AG is equal to F1 cos theta 1 and GE, in this figure GE is the same as BH. This is F2, this is F2, so this is also F2 inclined at theta 2 with horizontal, so this angle is also theta 2. So GE is the same as BH, that is nothing but F2 cos theta 2, and AE is this AD cos theta. AE is nothing but AD cos theta or F cos theta. This I have resolved. F cos theta, the horizontal component. F1 cos theta 1, the horizontal component. F2 cos theta 2, horizontal component of F2. So I can write here, and then that is F cos theta, this one is equal to F1 cos theta 1 plus F2 cos theta 2. Now I am multiplying throughout by the term OA. Multiplying throughout with OA, F into OA cos theta is equal to F1 into OA cos theta 1 plus F2 into OA cos theta 2. Why I have multiplied with OA? Let us see from here. What is this? Is OA. Theta 1. Theta is this angle between F and the horizontal. That will be the same as angle between the normal to this and the vertical. So this angle, this is also going to be theta. So OA cos theta is nothing but D. This OA cos theta is nothing but D. Similarly, OA cos theta 1. This is OA, this is theta 1. So angle between the perpendicular to F1 and the vertical. So this angle is theta 1. So OA cos theta 1 is nothing but D1. OA cos theta 2, angle between F2 and horizontal. So angle between the normal to F2 and vertical. This angle is theta 2. So D2 is equal to OA cos theta 2. OA cos theta 2 is D2. So we have proved F into D is equal to F1 D1 plus F2 D2. So the Variance Theorem is the moment of a force about a point is equal to algebraic sum of moments of its components about the same point or the same axis. So this will be very useful while doing numerical examples of several forces acting at different angles. So we have a numerical example based on this.